Hello, welcome back. In this video, we're given two functions, and we're going to test for symmetries. And I tried to list down the algebra for testing for symmetry. So for x-axis, we replace y by negative y for getting the equivalent form. And in the second case, y-axis symmetry, we have x replaced by negative x. And then in the last one, we replace both x and y with negative x and negative y, respectively, for the goal of getting the equivalent form. So the first function that we're dealing with is y equals x squared over x squared plus 1. So let's try this. So I'm going to replace y by minus y. So here we go. Minus y equals x squared over x squared plus 1. So let's write them all and then judge the symmetry at the end. So here we have y equals minus x squared divided by minus x squared plus 1. And for the last one, minus y is equal to minus x squared divided by minus x squared plus 1. All right, so let's analyze the first one. Well, as you see, the right-hand side of this one and this one is exactly the same, except the left-hand sides. One is y, the other one is minus y. We immediately conclude that there is no symmetry about x-axis because these are different forms. And here, if you simplify this expression, this is going to be x squared over x squared plus 1. Because these are quantity squares, and that's exactly the same as the function that I'm dealing with. So I'm going to put a yes here. And finally, simplifying this expression here, minus y equals x squared over x squared plus 1. As you see, this is very similar to the first case here, and we can immediately conclude that these forms are not the same as this one, so there is no symmetry about the origin. For part B, we follow the same strategy. In the first case, we replace y by negative to minus y equals x over x squared plus 1. For the y-axis symmetry, we replace x by negative x here, minus x divided by minus x squared plus 1. And finally, both x and y are replaced. So minus y equals minus x over minus x squared plus 1. And as you see, this form is not exactly the same as this form because even though the right-hand sides are the same, the left-hand sides are different. So we immediately conclude that there is no symmetry about x-axis. And for part B, let's simplify this. So this is minus x divided by x squared plus 1. Okay. And the left-hand side is y, left-hand side is y, but the right-hand sides are totally different because I have a negative x here and I don't have negative x here. So these forms are completely different, and I conclude here that there's no symmetry about y-axis. And finally, let's simplify this expression here. So you have minus x minus y, so why don't we multiply both sides by minus 1? So y equals x over x squared plus 1. Well, the good news is that this form is exactly the same as this form, so we do have a symmetry about origin. All right, the blue graph here is the graph for the first function, x squared over x squared plus 1. As you can see, there is a symmetry about y-axis. Just imagine like y-axis is like a mirror, and then you have the image here is reflected all the way across. And for y equals x over x squared plus 1, you have the orange graph. An orange graph, as you see, is symmetrical about origin, but not x-axis or y-axis. All right, thanks for watching. I'll see you in another video. Bye.